After drawing an Arduino Uno for our participation to the 4th Student Festival of Digital Creation, where we presented our hydropneumatic binary adder, my juvenile pursuits in electronics were awakened. This little board could really give me a chance for making my students get deeper into computing and their application. It may help me to put together a robotics team at my school. So I started reading, and all sorts of ideas were coming into my mind. This meant more reading and watching, and still more reading and more watching, till I decided to prepare a couple of projects to initiate my students and myself into robotics and microcontrollers in general. The first of them was no other but a balancing robot. I know that this type of project is not easy, but it is surely impressive, and I thought it will be very catchy for my students. After all, this type of project would quickly throw me into deep waters, which is what I really wanted at this stage, since summer holidays were starting soon. After watching this simple BeetleBot, and while waiting for my electronic components to arrive, I decided to build the first version of the balancing robot, but without using a microcontroller. A fellow teacher kindly offered me his son's broken remote control toy, which provided a very nice motor and gear module to play with. The next thing I needed was to build the brain of the balancing robot. This was a simple double-pole, double-throw tilt switch using paper clips and 2 ball bearings. I knew from the start that my attempt would be a total failure, which it was, but it gave me the chance to exercise my soldering skills. The electronic components finally arrived, and I could move to the next version of the balancing robot. What I needed first was a way to control the motor. I built this type of motor controller using the famous L293D H-bridge.
Here is my very first test with it, where the toy motor repeatedly moves for 4 seconds clockwise and then anti-clockwise for another 4 seconds.
This design uses Arduino's 5-volt regulated output to drive the bridge's logic and a second 6-volt power supply to drive the motor. The enable pin of the microchip is constantly set to high, which saves the use of one extra Arduino pin. With this design, there is no need for a regulator, and the motor can be controlled for bidirectional use as well as variable speed.
Previous measurements showed that the motor in a normal run draws just below 300 milliamps at 6 volts, which peaks to just above 1 amp when the motor stalls.
This means that the L293D is running at its limits. Look what happened to my breadboard when I removed the components to build the actual PCB of the motor driver. This can be overcome by parallel wiring the second half of the L293D, which is not in use. But I have not tested this yet. When building the final motor driver PCB, I added a heatsink just to be on the safe side. The next step was to build a type of accelerometer. I didn't want to use any ready-made boards or sensors, since I find them a bit expensive, and after all I wanted to experiment with my own approach to the problem. I cut a small part of a plastic pen casing, dropped a ball bearing inside it, and placed it above 2 photoresistors with an LED over it. Basically, I made a tilt switch using photoresistors, which is able to give variable tilt values. This is the schematic and the final PCB. In the meantime, I started making the platform for my balancing robot together with all the coding. Unfortunately, the performance of my design was not acceptable for many reasons. First, I was using a mechanical switch with all the problems this type of switch carries. Second, the switch was far too sensitive for the job. And third, even though it did give in-between values, the range was far too small for the balancing purposes. I was a bit disappointed from the results, but during my tests I came across to this video. This guy just uses 2 photoresistors and obviously a steady light source above them. I decided to give it a try. I took off the LED and the pen case with a ball bearing, placed the photoresistors some distance apart, looking upward at about 40 degrees, and guess what? I finally got it to balance. Thanks for watching.